Okay, we're continuing with our review, and we're still in the test 2 material, and we're doing rational exponents. All right, so we want to evaluate 27 to the negative 1/3. So first, let's put the 27 to the 1/3 in the denominator. In other words, move this to the denominator and change the sign of the exponent. Okay, now we're ready to evaluate the denominator. Now remember what an exponent of 1/3 means, that we're taking a cubed root. All right, so basically this x to the 1/3 is the same as the cubed root of x. Just another way of writing cubed root. And x to the 1/2 is square root, etc. So the cubed root of 27 is 3. So this evaluates to 1/3. All right, number 2, we know that when we have a fraction raised to a negative exponent, we can take the reciprocal of the fraction and change to a positive exponent. All right, so we're going to do 81 over 16 to the 3/4. First, we'll do the denominator. That is, first we'll take the 4th root of 81 and of 16. So let's do that. The 4th root of 81 is 3, because 3 to the 4th is 81. 3 times 3 times 3 times 3 is 81. And the 4th root of 16 is 2, because 2 to the 4th is 16. All right, so we took the 4th root, but we still did not cube this fraction, so we're going to do that now. 3 cubed is 27, and 2 cubed is 8. In number 3, we have an algebraic expression raised to a fractional exponent. We're going to first take the cubed root of what's inside parentheses. So we'll start with the cube root of 27 is 3. The cube root of x to the 12th, well, we take the cube root by dividing the exponent by 3. So we have x to the 4th. And the cube root of y to the 9th, again, divide that exponent of 9 by 3, and we have y cubed. All right, so we took a cubed root, and now we're going to square what's in the parentheses. So let's do that. So here we have 3 squared is 9. X to the 4th squared, multiply those exponents, and we have x to the 8. And y cubed squared, multiply those exponents, and we have y to the 6. Number 4, we're going to multiply x to the 2/5 times x to the 1/3. So when we multiply powers of x, we add the exponents as usual. Now let's just add 2/5 plus 1/3. So we're just adding these fractions in the exponent. We'll have to get a common denominator. Let's see, 15. All right, here to get a 15, we multiply by 3, and we'll do that numerator and denominator. To get a 15 here, we multiply by 5. All right, so this exponent is 3 times 2, that is 6. And this exponent is 5 times 1. And now we'll just add those two fractions in the exponent, and we get x to the 11 over 15. In number 5, we have a right triangle, so let's draw a picture. All right, a right triangle. One leg is 2. The hypotenuse is 3. And we have to find the other leg. So let's use the Pythagorean theorem that says that a squared plus b squared is equal to c squared, where c is the longest side, the hypotenuse. So in this case, that would be 2 squared plus x squared is equal to 3 squared. So that's 4 plus x squared is equal to 9. And we're just solving for x squared. So we get that x squared is equal to 5. and that means that x is equal to plus or minus the square root of 5. That's taking the square root of on both sides. All right, but we only go with the positive. All right, we're going to erase this negative over here because Rx is a length of a side of a right triangle. So a length is positive. So the answer is positive square root 5. In number 6, we want to determine if the lengths 7, 25, and 24 are the sides of a right triangle. So we're going to see if they satisfy the Pythagorean theorem. All right, that's a squared plus b squared equals c squared. Now, c has to be the largest side, so that would be 25. So we want to see is 7 squared plus 24 squared equal to 25 squared. That is 49 plus 576 equal to 625. And it is equal, so the answer is yes. In number 7, we want to find the area and circumference of a circle of radius 3. So we just have to remember the two formulas. The circumference is equal to 2 pi r, and the area is equal to pi r squared. All right, so the circumference is equal to 2 pi times the radius. That is 6 pi. And the area is equal to pi times r squared times 3 squared, or 9 pi. That's it. Number 8 says find the area of a triangle with base 6 and height 5. So we have a triangle. You don't really have to draw a picture for this one, but I'll just draw one like this. And this is the base 6 and the height 5. Oops, hold on one second. The height 5. So all we need is to know the formula for the area. The area is equal to 1/2 base times height. All right, so in our case it's 1/2 6 times 5, which is equal to 15.